Heat is an inevitable byproduct of manufacturing. However, waste heat can be recovered and harnessed. Processes that create excess heat are called primary processes. Those which use the recycled energy are called secondary processes. The generation of waste heat will differ from one facility to another based on the equipment they use. Therefore, it is best to start by identifying any processes which produce waste heat and ask yourself the following questions. Is the temperature of the waste heat hot enough to be useful? Some waste heat may not be. Typically, waste heat should have a temperature differential of at least 200 degrees Fahrenheit between the two processes to be useful. Is there another process that could use the waste heat? It is often harder to identify processes that can use recovered heat than it is to identify those which create it. Can the primary process deliver energy to the secondary process in time? Distance will be a limitation when heat loss is considered. As distance between the first and secondary processes increase, the transfer efficiency decreases. If the distance is too great, heat recovery is not economical. Is the waste heat overly corrosive? Some processes that expel harsh chemicals can break down carbon steel quickly. More expensive materials like stainless steel or aluminum will be needed for these applications. There are two common recommendations given by the IAC related to waste heat recovery. The first is to recover waste heat from equipment in the form of liquid, steam, and radiant heat. One good example of this is recovering heat from a boiler blowdown. In this case, heat from the blowdown water will preheat the feed water and reduce the amount of thermal energy required to heat the feed water once it enters the boiler. As a rule of thumb, when continuous blowdown exceeds 5%, this option should be considered. Similar actions have been recommended 155 times. On average, savings have totaled $31,400, and the cost to implement this recommendation has been $48,500. Typically, the payback period is 1.6 years. Another common way to recover heat is by harnessing flue gases. For flue gas recuperation, a heat exchanger is placed on the flue stack and feed air is forced through it before entering the equipment. This process preheats the feed air, reducing the amount of heating that must be done by the equipment. In general, processes that operate at 1600 degrees Fahrenheit or greater are good candidates for this kind of heat exchanger. Heat exchangers have been recommended to food processing facilities 163 times. On average, savings total $31,500, and the average implementation cost is $30,300. This upgrade will pay for itself in an average of 1.9 years. This concludes our list of recommendations related to heat recovery. Thank you for watching.